Example 18. Replace the force and couple moment system acting on the beam in by an equivalent resultant force and find where its line of action intersects the beam measured from point O. Okay, so first is we'll find the resultant force first, and everything else will follow. Okay, so we do uh okay, so the y component Fr sub y is equal to the sum of all forces in the y direction, assuming upward positive. Okay, so we have two forces, that's 4 kilonewton and 8 kilonewton, but our 8 kilonewton is subjected to at a specified angle with respect to horizontal. So we will resolve this one into f sub, let us call it 8y, and this is 8x, 8 sub x. Okay, so we do summation in the y-axis. So this is equal to 8 times positive 8 because our 8 kilonewton is going up. That is 8 times 4 over 5. And then minus 4 kilonewton going down. So this is equal to 8 times 4 divide 5. That's 6.4. 6.4 minus 4. So our F sub Ry is equal to 2.4. 2.4, this is in kilonewton. This is in kilonewton going up. Okay, next for our x component of our resultant force. So F sub R x is equal to the sum of all forces in the x direction, assuming to the right positive. So this is equal to, and we only have one force that goes to the right, and that is the x component of our 8 kilonewton, which is 8 times 3/5. So this is 8 times 3 over 5. F sub R x is equal to 8 times 3 divide 5, that's 4.8 kilonewton to the right. So therefore our magnitude of F sub R is F sub R is equal to the square root of F sub R x quantity squared plus F sub R y quantity squared. We substitute the values. This is square root of 4.8 squared plus 2.4 squared, and F sub R is equal to 4.8 squared plus 2.4 squared. Take the square root, and that is 5. 5.366, 563,146 kilonewton. And of course, our direction of or direction of F sub r. So that is theta is equal to the inverse tangent of F sub r y divided by F sub r x, which is equal to tangent F sub r y is 2.4. This is 2.4 divided by 4.8. So our theta is equal to 2.4 divided by 4.8. Inverse tangent is equal to 26.56505 degrees going up to the right. So of course, like we already calculated the magnitude of our resultant force. However, we are also tasked to find where its line of action intersects the beam measured from point O. So our beam has a total length of 1.5 times 4. That is 6 meters. So let us say we redraw our beam. How does our beam? A pin and roller. Okay. So we have our beam here. This is our pin. This is our roller. Okay. This is our point O. From here to here is 6 meters, right? Because 1.25 each. Now, of course, our resultant force is 5.36656314 kilonewton going up to the right. So it means our force is, let us assume that this is our F sub r following an angle of theta. And we are very much concerned with this distance, the perpendicular. This is where it intersects the uh, beam measured from point O. So what we're going to do is, we know that from principle of transmissibility, we can slide our force within its line of action, right? So what we can do is we can resolve our force here. It's F sub r y and F sub r x, right? Or if you want, pwede rin. However, we don't know. We are only concerned with the line of the point where our force passes through the beam. So here, and we will resolve our force into the x and y component. And now if we do moment summation about point O, we'll only consider F sub ry, which is the unknown, which is our D perpendicular, or our D, because, and we will not consider F sub Rx because the line of action of F sub Rx passes through point O. Okay, so if we do moment summation, okay, M sub R, resultant moment. Now, resultant moment that acts at point O, assuming counterclockwise positive, is equal to all the sum of all moment that acts at point O. So of course, when you talk about resultant moment, it refers to our resultant force, right? And our value for our resultant force, F sub r y, is equal to 2.4. So we use that. So we write 2.4 times its perpendicular distance, which is unknown, D, is equal to all the forces at the moments that acts at point O, which is 4 kilonewton, 8y, 8x, and our couple 15 kilonewton meter, which is clockwise. So therefore, a 4 kilonewton is clockwise as well. 8y is counter, 8x is clockwise. So we will start with 8y. So that's 8 times 4/5, 8 times 4/5 times its perpendicular distance of our 8y, that is 1.5, 1.5, 1.5. So that's 4.5 times 4.5, and then minus now. We start with, let us do 8x first. 8x has a perpendicular distance of 0.5 meters from point O. So that's 8 times 3/5. 8 times 3/5 times 0.5. And then minus our 4 kilonewton, which acts at 1.5 meters from point O. So this is 1.5. And then our couple, which is which is clockwise, 15 kilonewton meter. So this is minus 15. Okay, minus 15. This is equal to 8 times 4/5 times 4.5. 8 times 3 times 0.5 divided by 5. This is 2.4 minus 4 times 1.5. This is 6 minus 15. This is equal to 28.8 minus 2.4 minus 6 minus 15, and that is, this is 2.4 times D times 5.4 kilonewton meter. Divide both sides by 2.4. Then D is equal to 5.4 divide 2.4 is equal to 2.25 meters, because 2.4 has a unit of kilonewton. And this is the distance from point O, where our resultant force, which has a magnitude of 5.37, passes through the beam measured from point O.